Hello, you are welcome to another episode on Thomas Academy. Today we are going to be talking about kinetic theory of matter and gas law. Under this, we are going to discuss molar volume, atomicity of gases, and relationship between vapor density and relative molecular mass. Learning outcomes. At the end of this lesson, learners will be able to define mole, Avogadro number, molar volume, and the determination of the molar volume of a substance. Define and classify atomicity. Determine and explain the atomicity of gas molecules with examples. Define vapor density, relative molecular mass, and determine the relationship between them. This is starter video on molar volume. Definition of terms. Mole. This is the unit used for measuring number of particles of matter. Avogadro's number. This is the number of carbon atoms in 12 grams of carbon-12 and is numerically equal to 6.02 times 10 raised to power 23. Molar volume. Molar volume of any gas is the volume occupied by 1 mole of that gas at standard temperature and pressure, STP, and is numerically equal to 22.4 dm³. Example, we have a chlorine molecule and CO2 molecule. A chlorine molecule is diatomic, so we are going to multiply the relative atomic mass by 2. We are going to have 71 grams as the mass. And since 1 molecule of any gas at STP contains 22.4 dm³, and number of particles is 6.02 times 10 raised to power 23. CO2. To find the mass of CO2, we're going to use the relative atomic mass. Relative atomic mass of carbon is 12. Relative atomic mass of oxygen is 16. But because oxygen here is having 2 atoms, that's the atomic, we multiply by 2. 16 times 2 give us 32. 32 plus 2 give us 44. Volume at STP is 22.4 dm³ and number of particles 6.02 times 10 raised to power 23. Example 1. 5,000 dm³ of CO2 molecules are absorbed by the leaves of an Iroko tree every day. How many moles and how many grams of CO2 does this represent? Molar volume at STP equals 22.4 dm³. Solution. 22.4 dm³ of CO2 equals 1 mole of CO2. That's the standard. It's a law in chemistry. 1 mole of any gas at STP equals 22.4 dm³. This is standard in chemistry. So since 22.4 dm³ of CO2 equals 1 mole of CO2, then 5,000 dm³ of CO2 will now be equals to, we can cross multiply, that's 5,000 times 1, so that's 5,000 divided by 22.4. So this is comparison. We are comparing with the standard to get what? To get 223.2 moles of CO2. Molar mass of CO2 is 44 grams per mole. So 1 mole of CO2 is 44 grams. If 1 mole of CO2 is 44 grams, if 1 mole give us 44 grams, then 223.2 moles will give us 223.2 multiplied by 44. So we have 9,820.8 grams of CO2. Example 2. What volume of oxygen at STP will be obtained when 24.5 grams of potassium triiosochlorate 5 crystals are heated? Relative atomic mass are given as oxygen 16, potassium 39, chlorine 35.5. Solution. In this type of question, you have to write the equation of reaction correctly. 2 KClO3 equals 2 KCl plus 3O2. Now this equation of reaction is balanced. The molar mass of KClO3, we are going to calculate the molar mass. Molar mass of KClO3 using the respective atomic masses. So we have 122.5 gram per mole. But in the equation of reaction, we have 2 mole. So we're going to multiply this 122.5 by 2. So we're going to have 245 gram. So which means 245 gram of KClO3 produce 3 mole of oxygen, which is 3 times 22.4, which gives us 67.2 dm cube of oxygen. So this simply means that 245 gram of KClO3 produce 67.2 dm cube of oxygen. If 245 gram of KClO3 produce 67.2 dm cube of oxygen, then 24.5 gram will produce what? So it's simple comparison. 24.5 gram we produce, then we're going to cross multiply. 24.5 multiplied by 67.2, then divided by 245 gram. So this will give us 6.72 dm cube. If you divide 25.5 or 2, if you divide with 245, it will still give you the same thing. Multiply by this, it will give you 6.72. So, and if you multiply 24.5 by 67.2, then divide the result by 245, it will still give you 6.72 dm cube of oxygen. Atomicity. Atomicity is defined as the total number of atoms present in a molecule. For example, each molecule of oxygen, O2, is composed of 2 oxygen atoms. So atomicity of oxygen is 2. Classification of atomicity of molecules. On the basis of atomicity, the molecules can be classified as monoatomic, composed of 1 atom. When you hear the word mono, that's 1 atom. Example, helium, neon, argon. All noble gases are monoatomic. Diatomic, composed of 2 atoms, e.g., hydrogen molecule, nitrogen, oxygen, fluorine, chlorine. All halogens are usually diatomic. Then triatomic, composed of 3 atoms, e.g. O3, that's ozone. Tetraatomic, composed of 4 atoms, e.g. phosphorus. Example 1. Find the atomicity of the following molecule. HCl. Solution. The hydrogen chloride has 1 chlorine and 1 hydrogen atom. So it is atomicity. So its atomicity is 1 plus 1, that's 2. Example 2. What is the atomicity of CO2? The atomicity of carbon is 1, the atomicity of oxygen, O2, that's 2. So therefore, the total number of atoms will now be, for CO2, that's 1 plus 2, that's 3. So the atomicity of CO2 equals 3. We move to vapor density. Vapor density is the ratio of the mass of a certain volume of a gas or vapor to the mass of an equal volume of hydrogen, measured under the same condition of temperature and pressure. Relative molecular mass. The relative molecular mass of a gas or vapor is the ratio between the mass of 1 molecule of the gas or vapor to mass of 1 atom of hydrogen. Relationship between vapor density and relative molecular mass. So this is the relationship. To get the relationship, to derive the relationship between vapor density and relative molecular mass, we use the following expressions. Actually, you don't need to cram these workings, but you need to know the relationship. You need to know this formula. Vapor density equals to relative molecular mass over 2. So now on cross multiplication, we have relative molecular mass equals to 2 times vapor density. So you should not forget this. Relative molecular mass is twice vapor density. So test your understanding. So from what we have done so far, you should be able to solve this. Calculate the volume of 2.5 mole of oxygen. Calculate the volume of 2.5 mole of oxygen. This is very easy. 1 mole of oxygen at STP consists of 22 points, contains 22.4 dmq. So 2.5 mole will be 2.5 mole multiplied by 22.4. So if you know the standard, you have problem with question number 1. Same thing as question number 2. You should be able to do this. Determine the volume of 25.5 gram of ammonia. We're asked to determine the volume at STP. Polar volume of gas is 22.4. This standard, even if you are not given, you should know that molar volume of any gas at STP is 22.4 dm cube. So molar mass of NH3 is 17 gram. You have been given the molar mass of ammonia. So this one also is straightforward. You should be able to do this. Try it. And in case you don't know it, the solution is on this slide. On question number 3, atomicity of helium gas. This is straightforward. Of course, you should know that it's monoatomic. Find the atomicity of this. You should be able to do this too. Then question number 5, calculate the molecular mass of a gas if the vapor density of the gas is 22. You should be able to solve out this question. And in case you are having difficulty in solving any of the questions, the solutions is on this slide. So this is the solution to question number 1. Just like I said, you multiply 2.5 mole by 22.4. And the answer is 56.0 dm cube. Just question number 2, molar mass is 17 gram. So that's 1 mole. 1 mole of ammonia is 17 grams. So which means you have to convert 25.5 gram to mole. So if you convert 25.5 gram to mole, it's 1.5 mole. So 1 mole of ammonia contain 22.4 dm cubes. Then 1.5 mole, you multiply 1.5 times 22.4. Of course, answer to question number 3 is monoatomic. So, and this is the solution. Question number 5 is even straightforward. Molecular mass in the last part of the vapor density, the workings I showed you earlier, molar mass is twice of vapor density. And the question has given you vapor density, just multiply by 2. And we have 44. This question is simple, but you have to be careful. We have come to the end of today's lesson. So in this lesson, you have learned that molar volume of any gas is the volume occupied by 1 mole of that gas at STP and is equal to 22.4 dm cube. Atomicity is the number of atoms in a molecule of an element. And we have given examples comprised of noble gases, metal, respectively. Vapor density is the ratio of the mass of a certain volume of a gas or vapor to the mass of an equal volume of hydrogen, measured under the same condition of temperature and pressure. Also, we talk about the relative molecular mass of a gas or vapor is the ratio between the mass of 1 molecule of the gas or vapor to mass of 1 atom of hydrogen. Then we talk about the relationship between vapor density and relative molecular mass. It's given as relative molecular mass is twice vapor density. So we have come to the end of today's class. Don't forget to do your assignment. Try this assignment on your own. Thank you for joining us on Thomas Academy. And don't forget to subscribe so that when our next video comes up, you'll be the first person to get it. Thank you.